Cryptography includes symmetric and asymmetric encryption, digital signatures, cryptographic hash functions, key agreement protocols, blockchain, zero-knowledge proofs, and garbled circuits. Databases and data mining. A database is intended to organize, store, and retrieve large amounts of data easily. Digital databases are managed using database management systems to store, create, maintain, and search data through database models and query languages. Data mining is a process of discovering patterns in large data sets. Computer graphics and visualization. Computer graphics is the study of digital visual contents and involves the synthesis and manipulation of image data. The study is connected to many other fields in computer science, including computer vision, image processing, and computational geometry, and is heavily applied in the fields of special effects and video games. Sync2 equals transfer OK.svg. Synth kinematics high-res transp.png. 5cell.gif. HUD on the cat.jpg. Visible light eye tracking algorithm.jpg. CSG tree.png. 2D computer graphics, computer animation rendering, mixed reality, virtual reality, solid modeling, image and sound processing. Information can take the form of images, sound, video or other multimedia. Bits of information can be streamed via signals. Its processing is the central notion of informatics. The European view on computing, which studies information processing algorithms independently of the type of information carrier, whether it is electrical, mechanical or biological. This field plays important role in information theory, telecommunications, information engineering, and has applications in medical image computing and speech synthesis, among others. What is the lower bound on the complexity of fast Fourier transform algorithms? Is one of unsolved problems in theoretical computer science. DITFFT butterfly.png. Buy a pattern on sensor.svg. Opus quality comparison colorblind compatible.svg. Quality comparison JPG vs save for web.jpg. Meningioma resegmentation.png. TOMS, translation.svg. FFT algorithms, image processing, speech recognition, data compression, medical image computing, speech synthesis, applied computer science. Computational science, finance and engineering. Scientific computing, or computational science, is the field of study concerned with constructing mathematical models and quantitative analysis techniques and using computers to analyze and solve scientific problems. A major usage of scientific computing is simulation of various processes, including computational fluid dynamics, physical, electrical, and electronic systems and circuits, as well as societies and social situations, notably war games, along with their habitats, among many others. Modern computers enable optimization of such designs as complete aircraft. Notable in electrical and electronic circuit design are SPICE 60, as well as software for physical realization of new, or modified, designs. The latter includes essential design software for integrated circuits. 61. Lorenz Attractor YB.svg. QuarkWiki.jpg. Naftalen 3D Balls.png. 1U04 Argonaut.png. Galvsloschebach, low resolution.gif. Pluchaquil.svg. X-ray of hand, where bone age is automatically found by BoneXpert software.jpg. Elmerpump.heaterkirchen.png. Barschlut1.png. Numerical analysis, computational physics, computational chemistry, bioinformatics, neuroinformatics, psychoinformatics, medical informatics, computational engineering, compute, social computing and human-computer interaction. Social computing is an area that is concerned with the intersection of social behavior and computational systems. Human-computer interaction research develops theories, principles, and guidelines for user interface designers. Software engineering. Software engineering is the study of designing, implementing, and modifying the software in order to ensure it is of high quality, affordable, maintainable, and fast to build. It is a systematic approach to software design, involving the application of engineering practices to software. Software engineering deals with the organizing and analyzing of software. It doesn't just deal with the creation or manufacture of new software, but its internal arrangement and maintenance. For example, software testing, systems engineering, technical debt, and software development processes. Discoveries. The philosopher of computing Bill Rappaport noted 3 great insights of computer science. Sad smiley 62. Gottfried Wilhelm Leibniz, George Boole's, Alan Turing's, Claude Shannon's, and Samuel Morse's insight. There are only 2 objects that a computer has to deal with in order to represent anything. Note 4. All the information about any computable problem can be represented using only 0 and 1, or any other bistable pair that can flip-flop between 2 easily distinguishable states, such as on/off, magnetized/demagnetized, high voltage/low voltage, etc. Alan Turing's insight. There are only 5 actions that a computer has to perform in order to do anything. Every algorithm can be expressed in a language for a computer consisting of only 5 basic instructions. Sad smiley 63. Move left 1 location. Move right 1 location. Read symbol at current location. Print 0 at current location. Print 1 at current location. Corrado Bom and Giuseppe Jacopini's insight. There are only 3 ways of combining these actions into more complex ones that are needed in order for a computer to do anything. 64. Only 3 rules are needed to combine any set of basic instructions into more complex ones. Sequence. First do this, then do that. Selection. If such and such is the case, then do this, else do that. Repetition. While such and such is the case, do this. Note that the 3 rules of Bohm's and Jacopini's insight can be further simplified with the use of GoTo, which means it is more elementary than structured programming. Programming paradigms. Programming languages can be used to accomplish different tasks in different ways. Common programming paradigms include functional programming, a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids state and mutable data. It is a declarative programming paradigm, which means programming is done with expressions or declarations instead of statements. 65. Imperative programming, a programming paradigm that uses statements that change a program's state. 66. In much the same way that the imperative mood in natural languages expresses commands, an imperative program consists of commands for the computer to perform. Imperative programming focuses on describing how a program operates. Object-oriented programming, a programming paradigm based on the concept of objects, which may contain data, in the form of fields, often known as attributes, and code, in the form of procedures, often known as methods. A feature of objects is that an object's procedures can access and often modify the data fields of the object with which they are associated. Thus, object-oriented computer programs are made out of objects that interact with one another. 67. Service-oriented programming, a programming paradigm that uses services as the unit of computer work, to design and implement integrated business applications and mission-critical software programs. Many languages offer support for multiple paradigms, making the distinction more a matter of style than of technical capabilities. 68. Academia. Conferences are important events for computer science research. During these conferences, researchers from the public and private sectors present their recent work and meet. Unlike in most other academic fields, in computer science, the prestige of conference papers is greater than that of journal publications. 69. 70. A proposed explanation for this is the quick development of this relatively new field requires rapid review and distribution of results, a task better handled by conferences than by journals. 71. Education. Computer science, known by its near synonyms, computing, computer studies, has been taught in UK schools since the days of batch processing, mark-sensitive cards and paper tape, but usually to a select few students. 72. In 1981, the BBC produced a microcomputer and classroom network, and computer studies became common for GCE O-level students, 11-16-year-old, and computer science to A-level students. Its importance was recognized, and it became a compulsory part of the national curriculum, for Key Stage 3 and 4. In September 2014 it became an entitlement for all pupils over the age of 4. 73. In the US, with 14,000 school districts deciding the curriculum, provision was fractured. 74. According to a 2010 report by the Association for Computing Machinery, ACM, and Computer Science Teachers Association, CSTA, only 14 out of 50 states have adopted significant education standards for high school computer science. 75. Israel, New Zealand, and South Korea have included computer science in their national secondary education curricula. 76, 77, and several others are following. 78. See also: computer engineering, computer programming, digital revolution, information and communications technology, information technology, list of computer scientists, list of computer science awards, list of important publications in computer science, list of pioneers in computer science, list of unsolved problems in computer science, programming language, software engineering, notes. 1 in 1851. 2. The introduction of punched cards into the new engine was important not only as a more convenient form of control than the drums, or because programs could now be of unlimited extent, and could be stored and repeated without the danger of introducing errors in setting the machine by hand. It was important also because it served to crystallize Babbage's feeling that he had invented something really new, something much more than a sophisticated calculating machine. Bruce Collier, 1970. 3. See the entry Computer Science on Wikicode for the history of this quotation. 4. The word anything is written in quotation marks because there are things that computers cannot do. One example is, to answer the question if an arbitrary given computer program will eventually finish or run forever, the halting problem. References. 1.
Yes, good. We have 5 minutes left. So that's a lot of information. That was last 87 June 2022, and I think I have to look this in Wikipedia, because there was more I like to download, but this list will grow and grow and grow. You know, we're going to read computer software engineering. There was a lot of stuff there. But we have 3 or 4 minutes left. Now it's 3 p.m. and I still need a shower and a shaving. But I will put this computer science
computer science.
Back to Wikipedia. Search insets computer science. Yes, that's the document there. Then I will try find, but I think I better do it. I sit alone. I don't need to have a camcorder running, but I have looked through that. That was some more I like to read about. But of course we can do it a few minutes. No, there's something more, but it's just getting bigger and bigger. There's more and more and more. But you mentioned some old computers. The history, the Agabus. That's just for fun. I like to, and this mechanical calculators, that's the forerunners for computers. And this one, Charles, father of computers, we need to read about him. Gottfried Leibniz. We can take few one, but not everything, because it's just getting bigger and bigger. Yes, New York we can read, but there's nothing about that. At least like to read when I'm doing this many days. So I have to find, but we cannot do everything because it will take forever. There's 6.5 million articles, but that's more easy. No, that's computer engineering. We need some of that. So I'm not going just to select all this, because then I will have 100. I will got 100 different kind of PDF. That will take me 2 months to record. Will not do that. I'm interested in the computer hardware, and that's computer engineering and how the CPU, you're making the CPUs and transistors. Yes, we cannot just start to download all this PDF, because that will I can do that later, not now, because that will take forever. Yes, computer engineering. That's the one there. Processing units, microarchitecture. Processor design. But not everything, because that will just be bigger and bigger and bigger. I think we just do that. This was that too many links. No, we have software engineering. Yes, software engineering. We need to have that. Digital revolution. Could have that too, but not, maybe not do information list of computer. List of unsolved problems. Yes, but just download it. We cannot take everything, because that's just too many. Now the video splits. I will go. I will have to download all this again. I will go to my kitchen, get some cola.